What's up, guys? So, today, this is more of a problem solving video for multiple reasons. So, number one, I'm going to be covering problem solving and, well, structured programming and basic. Do I know basic? Do I plan on learning basic? No, maybe. But this book, I've had it for about a year. It was my dad's programming, basic textbook from college. So I saw it on his bookshelf a while ago, and he might have been even throwing it out. So anyway, I was looking through it, and this is honestly one of my favorite books of learning kind of the problem solving within programming. Even though basic isn't a language I'm focusing on, turns out it's universal, but I love the approach in this book because, this book is from 1979. So, programming's still pretty young. Like, the steps you had to do to, run a program, was, there was a lot more to it then. You couldn't just hit, the compile button or whatever on your computer and you see instant results. He was telling me then, you had to take a set of cards and get it, run it. And even then, the book admits it's your first time, writing any program isn't going to work. So that had to be very tedious. And then these are still in the book. These are, the printouts and stuff, but there's a lot of similarities. So basic is the beginners. I knew that at one. I always keep forgetting. Hold on a second. Beginner's all-purpose symbolic instruction code. So, and so it's a programming language that was definitely created for the beginner and to take programming and just the pure code aspect of it and put it in the hands of people like my dad, who you can tell by the notes in here, he didn't quite get it. He did, he's smart, and he was, he's an accountant, CPA, so a lot of this programming language is good for those basic formulas, and it's cool to see the limitations of the time where now we just take so much for granted. So it makes me appreciate what we have and what, and where we've been. But the problem solving steps are the same. And this is what I want to focus on today really quick. And again, this is a test too, to start to do tutorials where I can go over things, test screen sharing, video editing. I spent all of yesterday just trying to figure out something so easy and basic and some video editing software, DaVinci Resolve. So this is kind of a test, but also this is a topic I really want to go over, and I think this book has something to offer because I've had a lot of programming books, and I've even bought how to think like a programmer, but this one, and how it just breaks it down in such a fundamental way, I think it's missed in a lot of books, but maybe I'm wrong. But still, I really enjoy this book. Obviously there's some of it that I'm, if it's really in depth, goes into the syntax and other things, but there's a lot of problem solving. So we're going to go over the 6 problem solving principles that are covered in the book. And this is one of the first chapters. And I'm glad it starts out with this. And I think more books like this, or programming books should have a bigger problem solving section, because that's what being a programmer is. You're problem solving, and that's what I really love doing. So number one, I agree with completely. So you want to understand what you're being asked to do. So a lot of times, if you're doing a coding challenge, program coding challenge or whatever, you're trying to solve a problem, you try and just jump into it all at once. You just start typing, and you may not understand fully what you're being asked to do, or maybe what you're being asked to do isn't something within your skill set, so you have to do some research. You have to understand what the problem is wanting and what, again, you're being asked to do. That's why so many questions, like if you do like challenge sites, reading everything first, and you start to break it down, and just with how it says, how it states certain things. So I think that's obviously a super important one, and 100% still relevant today. You have to understand what you're being asked to do to even start it. So number two, again, super, super important, and identify all problem input and output data, assign a variable named to each input or output item and listed in the data table. So the data table, that book is all about that, but you can go about this in a lot of ways. If you just write stuff down, there's flow charts, which I'm going to start to brush up on. But essentially, what are you trying? What do you get, and what are you trying to, create? What are you trying to get out of that? So, what data do you have to start with, and what do you need to end with? So that can be, you can start simple. I mean, just writing, the names, but it's important to know these things, because you might start with an integer and then it needs to go into a string, and there's all kinds of limitations within that, which I think is another topic that really needs, can confuse the beginner programmer, like myself, especially early on, is what each one of those could do. Because there's obviously things you can do with strings and can't do with integers and floats, and so it's glossed over a lot because it's so fundamental and simple, and it is easy to have in surface level understanding, and perhaps that's enough. Maybe I'm overthinking this, but so you have to know what you're taking in, what you're putting out, and that's going to help you design those steps. And that leads me to number three: formulate precise statement of the problem in terms of the input and output data, and make certain there are sufficient input items provided to complete the solution. Well, this one I think could be refined a little bit. This is literally straight from the book, and again, not bad for a book from 1979. So I take that as too. You have to understand: are you missing something? Do you need more? Do you have all the data you need? Do you have what you need to complete the problem? And then that starts to help you put together, your statement, your function, whatever, your algorithm, and but that also makes you, if you figure out if it's sufficient, hey, what else? If it's not, what do you need to get there? So what do you have missing? So I think that's an important part, is finding the missing thing, which I'm not great at math, or wasn't. So in that, you're always trying to find variables. So and this one totally relevant, useful, and we could probably spend a whole video on each one of these topics. So I'm just going over these really quick. Perhaps this will help you the same way it did me. But so number four, the sequence of steps to produce what you want out of it. And you start to really get the beginnings of your algorithm. For most of us, if we are doing easy problems, we kind of skip straight to this step, or we kind of skip to the end, and go straight to trying to just put an algorithm down. And but this one's really kind of representing it as a flow diagram, which I'm starting to appreciate. I don't want to do too much of it right now, because I need to brush up on the flow diagram specifics. So if you see here, this book is filled with flow diagrams, and I think they're super useful. But for instance, the different shapes, I would like to know more, and I don't, there's a little few odd things in this book that I would change now. But so now you're starting to formulate, put together. Well, you've already done some of that in the previous step. So number four, you're starting to then produce what'll be your program. So the flow chart, this could be pseudo, this is kind of pseudocode, which I don't do a lot of, but I need to start doing it. I'm going to start practicing more of these problem solving principles, even on things that I know how to do, if that makes sense. And I want to demonstrate that in another video because I'm learning this, I'm really trying to hit on this and get it down now so I'm better at it later. Even, so it's easy, it's gonna be easier to start with something I know. Anyway, so you start to have the beginnings of your algorithm. It's probably in a flow chart. So number 5, it goes from, you have first draft to then something that can be implemented and I love how it says programming language to be used, because basic wasn't meant to be the end, the end point. It's just a jumping off point. So that's why these steps are so universal, and that's kind of missing from a lot of books. So again, then you're still listing some stuff, there's the data table. By this point, yeah, you should have a pretty good idea of how your program should flow. And then number 6, turn it into a program. So this should be something, you'd start, put it into your code editor and run it and see what happens. And it, if you're lucky, it works. And hey, if not, time to, go back a step or two. So yeah, I really like these. It's 6 problem solving principles from a book that, I doubt many people use this. And, there could be better versions of this, and this isn't the only book to put these out there. But there's so many examples of this type of problem solving and breaking it down in such a basic level that I think is really helpful. So probably, again, the one that stuck out to me the most is understand what you're being asked to do. Pure and simple, that's so important when learning programming and trying to wrap your head around a problem, is trying to understand what you're being asked to do, but also what do you have to work with and what does it have to be. So a lot of times, I might, especially early on, I was struggling with, well, why isn't this working? And I was trying to treat an integer as a string, and then there's a lot of there's a lot of things that can go into converting it. And so then you start to really think about the problem and the steps and visualizing it. Again, pseudocode's great. I would probably go from a flow chart to pseudocode, and then you start to really probably refine that flow chart and pseudocode into more concrete syntax, and then you're ready to program. So obviously, 1 through 6, if you don't feel like you need to go to 1, 2, 3, 4, 5, 6, I think there will be ones that'll, it's good to start, to focus on one of these instead of just, to a program, so many times we go from number 1 to the last part of 6. So we're just being asked to do something, and then we try and turn that into a program. And hey, if you're smart enough, or if the problem's simple enough, that's gonna work. And if you're just trying to earn experience points on a coding challenge site, whatever, but to actually go through these steps, I can see I can see what it's gonna do. I can see how it's gonna be beneficial, because my goal is to actually do this professionally at some point, hopefully soon. But you need to be able to describe and explain what you're doing. That's why there's, hey, comments. And that would be a good time to include that, within one of these steps, and start to do some comments and being able to explain something, and state clearly the sequence of steps. So it's that to me, that means probably readable code. If you have clear, steps to get what you want to do, that means, hey, this could be useful in a lot of other ways. It's not just language specific. And that's why, maybe, you solve this, and, it could be done in Python. Because, there's so many problems in here that could be solved in seconds, in Python, literally. And just the limitations of the language it's interesting, but also the same things are still there. I mean, memory management isn't really a issue with Python too much for the, especially the beginner. But I think it's important to know why. So, and that's why I don't really view my time as going through C++ as wasted. So anyway, so those are the 6 problem-solving principles. I just wanted to share this and start to do better video editing. It may not still be perfect, but it should be better, and then I hope to get a better camera, mic, and all that. So thanks for watching. Until next time, look forward to more programming videos that actually have programming and stuff in them. But these were the 6 problem-solving techniques from an old basic textbook.